Welcome all. Myself, Dr. G. Brindha from Department of Computer Science and Engineering from the college, St. Joseph College of Engineering, OMR, Chennai. Our topic today is multiplexer. Multiplexer is otherwise termed as MUX. This topic is under the subject Digital Logic. This is a core paper for the electronics people and computer science people. This is the base of the all computings, right? So that is multiplexer, that is this concept is dealing with the zeros and ones, so which is a digital concept. So with multiplexer, name specifies that there will be a multiple input with single output. Multiple inputs will be given as the inputs for the device, and output will be taken as a single output. So which means that it is of a data selector. This is of a data selector. This is otherwise named to be of a data selector. So based upon our applications, multiple data will be given as the input, and particular based upon our application, particular output will be taken as the output. The basic block diagram for this multiplexer is 2 power n cross 1. So which means that single output with multiple inputs. Multiple input is of the order of 2 power n. So n over here is defined as 0, 1, 2, 3 up to infinity. So based upon that, is this 2 power n configuration defines as if it is 2 power 0 single input, 2 power 1 2 input, and 2 power 2 it is of 4 inputs. So depending upon this configuration of inputs will be fed, that is these inputs will be kept in a queue, and based upon our application particular input will be taken as output with the help of the select lines. So select lines decides which particular input will be taken as the output. So select lines will be of the configuration n. Therefore, actual block diagram for our multiplexer is 2 power n cross 1 with n select lines. So if we are having 4 inputs, therefore select line will be of 2. So which means that 2 power 2 is equal to 4. So this n is the number of select lines, and this 2 power 2 is the number of inputs. So in which output will be of a single output. This is the basic concept of the MUX. So based upon our application, 8 cross 1, 16 cross 1, 32 cross 1 can be configured. Minimum is 2 cross 1. So 2 cross 1, which means that 2 power 1, which means that 1 select line. If it is 4 cross 1, 2 power 2, which means that 2 select line. If it is 8 cross 1, 2 power 3, which means that 3 select line. So depending upon it, you can configure it. This is the basics of the multiplexer. So first we'll see about the basic design structure of the multiplexer. This is a UG syllabus. So which means that all the basics first will be covered, and the application oriented MUX configuration will also be taught you in this session. First we'll go with the 4 cross 1 MUX design. So based upon this design, you can explore with 2 cross 1, 8 cross 1, 16 cross 1. So as a UG syllabus, this 4 cross 1 and 8 cross 1 will be frequently asked. So 4 cross 1, first go with the basic block diagram. So 4 cross 1, 4 inputs. So 4 inputs, I am taking the input as I0, I1, I2 and I3. So 4 cross 1. So 1 output I am giving the label as Y. And then we have 2 select lines. Those 2 select lines I am labeling it as S0 and S1. Okay, so based upon our select line is of a digital concept oriented, and therefore our truth table will be of S0 and S1 and inputs of I0, I1, I2 and I3, and the output is Y. So only one output, and this is the input and this is the select lines. So depending upon our select line, particular input will be taken as the output. For example, so select line is 2, therefore it is of a digital configuration, therefore the inputs will, that is your order will be of either zeros and ones. So combination of zeros and ones with the two bits is defined as 0 0, 0 1, 1 0 and 1 1. So it is given as 4 combinations, and therefore 4 inputs can be controlled using these select lines. So when our configuration is 0 0, so which means that whatever the content over there in I naught will be taken as the output, irrespective of whatever the content over there in I1, I2, I3. Whenever a select line is 0 0, the content over there in I naught will be taken as a output. Similarly, whenever a select line is 0 1, the content over there in I1 will be taken as the output, irrespective of the other inputs. Similarly, 1 0 is nothing but I2, so which means that I2 will be taken as the output, and other content, it can be anything. Similarly, 1 1, 1 1 is nothing but I3. So in I3, whatever the inputs given in the I3 will be taken as the output, irrelevant of the other set of inputs. So which defines that in all the things, that is in all inputs I0, I1, I2, I3, a content will be there in all sequences. Depending upon our select lines, that particular content will be taken as the output. Okay, so that is, it will concentrate only upon the particular input based upon our select line. This is said to be of a mux. So that's why it is said to be of a data selector. So it selects the data, input data, and it takes that as a output. That is why it's said to be of a data selector. This circuit is said to be of a data selector. Okay, so similarly for 4 cross 1, it is of this configuration of this. If it is a 8 cross 1, 3 inputs, therefore S0, S1 and S2, and output will be of the I0, I1, I2, I3, I4, I5, I6 and I7. So totally 8. So 3 combinations. Therefore S0 may have 0 and 1, and similarly S1 may have 0 and 1, S2 may have 0 and 1. Therefore S0, S1, S2, all possible combinations will be of 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 1 0 1, 1 1 0 and triple 1. So if you count, it will be of 8 combinations. That's why it is said to be of a 8 inputs. This is the basic logic behind your multiplexer. Okay, so 4 cross 1 diagram, the truth table is this, and 8 cross 1 truth table will be of this. Okay, so similarly you can expand based upon the configuration given. Similarly for 16 cross 1, 16 cross 1 is nothing but 2 power 4. So for 4 select lines. So 4 combinations, which means that S0, S1, S2, S3. So which means that it will start from 0 to 15. 0 to 15 binary values. Okay, so same concept, same logic. Only thing is, depending upon the configuration, the truth table structure will get vary. And next is this is the logic diagram. This will be of a logic diagram. This will be of a truth table. And next will be the circuit diagram. So circuit diagram based upon this is, so S0, S1, values are 0 and 1. Therefore, S0, S1. Values are 0 and 1, right? So this line represents value is 1. And if you connect a NOT gate to that, then this line will represent a value to be of a 0. If this line is 0, this line is 1. Okay. So here solid line represents 1 and negated line represents 0. So which means that this is S0, this is S0 bar. Similarly, S1 and this is S1 bar. S1 bar. Okay, so this 0 represents S0 bar, and 1, this 0 represents S1 bar. Similarly, this combination is defined as a variable as S0 bar S1. This is S0 S1 bar. This is S0 S1. Okay, so such a way you have to connect the diagram over it. And you have I0, I1, I2, I3 as inputs, and therefore 4 inputs, taken those inputs as I0, I1, I2 and I3. So this is a line which carries the information, data, information or data. Okay, so first combination is Y, that is whenever my S0, S1 or 0, 0 I naught will be taken as the output. Therefore, your diagram should be of S naught S1 0 0 represents S naught bar and S1 bar. Therefore, S naught bar S1 bar connected with it with the I naught. Whenever my combination is S naught bar and S1 bar, my I naught should be taken as the output, and therefore we are supposed to go with the AND gate. As per AND logic, when all the inputs are active, output will be active. If any one of the input is deactive, output will be deactive. So which means that my 0 as per AND 0.1 is 0, 1.0 is also 0, only 1.1 is equal to 1. So this 1 represents active, 0 represents inactive. So only when all the inputs are active, output will be active. So as per this gate, whenever these two lines are active, then I naught will be taken as the output. This is my first combination S naught and S1. Similarly, S naught 0, S1 1, which represents S naught 0 is nothing but S naught bar, S1 is 1, therefore S1. So which will be connected to the input I1. So this is I1. Similarly, I3, S naught is 1, S1 bar. That is S1 is 0, therefore S1 bar. Therefore, S naught and then S1 bar, which will be connected to your I2. This is of I2. Similarly, last case I3, both S0 and S1 are 1 1. Therefore, S0 and S1 both are 1 1. So whenever these two lines are active, my I3 will be taken as the output via these AND gates. This is first AND gate, second AND gate, 3 and this is fourth. All these are three input AND gates. So whenever these three inputs are active, whatever the information in I0 will be taken as the output of this AND gate. Similarly, I1, I2 and I3, and as per our marks, at a time only one input should be taken as output, right? So which need to be connected to the OR gate. OR gate logic is nothing but 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, 1 plus 1 is equal to 1. So which means that when any of these 1 is active, output will be active. That is the OR logic. Okay, so as per this S0 and S1 condition, based upon this law, whichever line is active, only one AND gate will be active. Okay, because here S0 is equal to S0 bar and S1 is equal to S1 bar, and here it is S0 bar and S1 bar. So at a time, so the only these two inputs at a time, either with these two inputs they are given with the for logic. So in this for logic, at a time only one combinations only will be active. So which means that any of these four AND gates will be only one AND gate will be active at a time based upon this S0 and S1 combination. So okay, so whenever I0 is active, that will be as output. Whenever I2 is active, that will be as output as per our OR logic. So this is the logical diagram for your multiplexer. So similarly, you can expand this for 8 cross 1, 16 cross 1, 32 cross 1, depending upon our applications. So you people as a UGP students, you people carry out with the build the circuit for 4 cross 1, try to build the circuit for 4 cross 1, 4 cross 1 it is given already, and 8 cross 1 and 16 cross 1. Maximum 4 and 8 will be asked, 16 is rarely asked, so 4 cross 1 will be frequently asked. And in usually this marks will be an important topic, and it will be in a question paper either in 2 mark or in 13 mark. So if it is in 2 marks, it will be asked as 2 cross 1. So 2 cross 1 is very simple, that also we can see it over here. So 2 cross 1, 2 inputs, therefore 2 cross 1, 2 inputs and 1 output. So one output I am labeling it as Y, inputs I0 and I1. So 2 cross 1, 2 power 1 cross 1. So which means that single input, yes. So single input I am labeling it as yes. So when this is the case, yes. So single either 0 or 1. So I0 and I1. So whenever S is equal to 0, I0 will be active. So I0 will be your output. And whenever s is equal to 1, I1 will be output and I1 will be output. Very simple logic. So with this, when you draw a structure, S and S bar, because yes you have a value of 0 and yes you have a value of 1. Whenever it is 0, it is S bar. Whenever your value is 1, it is S. So this is S. So this will be S and this will be S bar. Okay. So when you draw the logic diagram, so first one is S bar. So S bar I1. So it is a 2 input AND gate is enough because it is of a 2 output. Therefore I naught. Similarly, S I1. So this will be the logical diagram for your I1. Similarly, either gates 1 and 2, only one will be active at a time based upon the S information. Therefore, your output will be of OR gate Y. So this will be the logic diagram for 4 cross 1 and this will be the logic diagram for your 2 cross 1. Right. So with this you can able to manage with the basics of the multiplexer.